Hi, welcome back. Today we're going to talk about average value. And average value, we saw a little activity yesterday, and we determined to get the average value of a function, we can use our little formula right here. 1 over b minus a times the integral of f of x dx. Now, where f of x dx is defined to be the area under a function, and b minus a is the length of the base of our function. So if I have a function right here, we want to find the area from a to b. My area is this part. That's my integral part from a to b. But this is my b minus a, and that's my base. And recall from yesterday, what this is saying is we can draw a rectangle that has the exact same area of our region under the function, and it's going to be under the same base here. So this b minus a. What we're trying to find today is the height. That's that average value. And what this is telling us to do, we take our area, which is the integral, the area, and we divide it by the base, which is how we would find the area of this rectangle. We would take the height of our rectangle. We would take the area of that rectangle and divide it by the base. So let's see an example here. We're riding a bike with the following velocity shown. They're saying use a right-hand Riemann sum. We've seen these before. Riemann really liked rectangles with 3 subintervals to find the average velocity of the bike. So how do we find average velocity? Well, from physics, we know that velocity is your displacement. Sometimes we call it distance, but it's technically should be called displacement, divided by your change in time. So what we have to do is find the displacement. Well, from physics, if we're given a velocity time graph, we know that the area under velocity time graph is displacement. And that's from physics. So the area under a velocity time graph is displacement. So we're going to do this real quick. So we want to first find the displacement of the bike. So to do that, we have to find the area. And this is what our integral will look like. 0 to 9. Remember, integrals find area of our velocity function dt. So again, and if you think about this, it's saying velocity times time, which is again displacement. We can see that here. If I take my velocity multiplied by time, I get displacement. To solve this, they tell us to use a right Riemann sum. So we get 0, 2, 5, 9. We're going to make rectangles. 0 to 2 is my right-hand side. That's 10. 2 to 5 on my right side, that's 15. And then from 5 to 9, we're going to choose the 17. So we can say our area is about the following. I'm going to take 10 times 2 plus 15 times 3 plus 17 times 4. And if I simplify that, what's that? 20 plus 45 plus 68. And that's going to give us 133. So let's talk about units here. Now this is one of the toughest things we're going to do in calculus, talking about units. Velocity, we know, is in meters per second. dt, well, that's my change in time, is seconds. Those cancel, and we're left with meters. So this 133 is the distance we traveled in meters. Now, but remember, I want my average velocity. So what do I have to do now? Well, to get our velocity, our average velocity, we're going to take that distance that we traveled, that integral, and we're going to write it this way, and divide it by the change in time, 9 minus 0. Well, we already found the top was 133 meters. The bottom is over 9 seconds. So there is our velocity, 133 over 9 meters per second. And there's our average velocity using our formula that we talked about yesterday, that we discovered yesterday. So let's talk about average value and, again, talk about a little bit more about where it comes from. We want to find the average value under this parabola on the domain 0 to 2. Step 1, we find the area. So if I were to kind of graph this function right here, I know what this looks like. It'll look something like this. Okay? We want to find the area from 0 to 2. I can do that. That's what my integral does for me, from 0 to 2, negative x plus 4. Don't forget your dx. And that's going to give, whoops, I don't know what's going on with this yet today, and that's going to give us negative x squared over 2 plus 4x, and from 0 to 2. Using your FTC, sorry about that, I don't know what's going on with my pen today, minus f of 0, big parentheses, 0 is nice, it just goes away, plug in the 2, this is going to become negative 4 over 2 plus 8, and again minus 0, and if I simplify this, this isn't so hard to do. What's negative 4 over 2 is 2, negative 2 plus 8, and that just becomes 6. So the area from 0 to 2 is just 6. Now, what average value really is saying to do is we can create a rectangle on the domain 0 to 2. This rectangle will also have an area of 6. What we want to do is find the height of that rectangle. Well, if this is my base, this is my height, I know to get the area, it's just base times height. Later on, we are going to call this theorem right here the mean value theorem of integrals. We saw about MVT earlier this year. So I take my area, take my base, which we know is 2, times it by the height. Therefore, I can calculate the height as being 6 divided by 2, or 3. And we can verify this using our little formula right here. Our little formula to find the average value would be the following. 1 over 3, whoops, not 3, that's what we're looking to. 2 minus 0, and the area from 0 to 2, negative x squared plus 4 dx. Well, this is just 1 over 2, and we found the area here by using our integral, which was 6, and we got 3. So we get the same thing. So all average value looks for, all the average value says, is that we are trying to find the height of a rectangle. And that's average value. So let's talk about this thing we mentioned earlier about this thing called the mean value theorem of integrals. If f is a continuous function on a domain, there exists a number c such that we can take the value of that c, so this is like saying the height of my rectangle, multiply that by, remember this b minus a, if I take a look here, that's that b minus a, that's the base of our rectangle, and that's going to equal this integral. Well, what does an integral find but the area under the curve? And that's what this says. The area of a rectangle is equal to the area under the function. So what the mean value theorem says is that there exists a value somewhere between a and b that's going to give me a height that's going to form a rectangle that has the same area. So if this is my function f of x, there's my function f of x, I know its area. What the mean value theorem says is I can find a x value that's going to form a rectangle that has the exact same area under my function. And what we want to do is find this value. Our goal is to find c, so that will make this happen. Now, if we solve for f of c, if we solve for f of c, notice we divide by the b minus a, and we just get our average value function, where f of c is just the height. Whoops, I already wrote that down there for you. Where f of c is just the height of our rectangle. So we're just forming a rectangle here. So let's see here. So let's find the following average values here. And this is really easy to do. We'll take a look at one here, and then we'll pause, and so we'll go to the next video. So they will say, find the average value, and there is a formula for it. Notice up here, one thing we like to call it, I don't know if we noticed this literally becomes your favorite. So that's a little notation that we use. So when we write this, we actually call this our fave. F sub fave is, my rule says take 1 over b minus a. Well, there's a and b. 1 over 4 minus 0 times the antiderivative of our function, 4x minus x squared dx. We're just going to use our formula here. So if we were to integrate this one, this becomes 2x squared, from 0 to 4, minus x cubed over 3. Now notice, I haven't forgotten about this 1 over 4 here. I'm just going to do that last. From 0 to 4, use your FTC, f of 4 minus f of 0, big parentheses. 0 is nice. Everything there just becomes 0. Plug in the 4. Be careful. We get 16 times 2, which is 32, minus, plug in the 4. We should know 4 cubed as being 64 over 3. So to get my average value, we're going to take that area that, it's a weird looking equal sign. We're going to take that area we just found, that 32 minus 64 over 3, and multiply that by this 1/4. I really don't know what that equals because I don't simplify. And that would be our average value. All right, take a pause here. Go to video number 2. We'll take a look at some more.